This is part 1 of 3 short lectures on the topics of validity, reliability, and statistical power. These are foundational concepts for understanding research and research methods. And my goal is to start laying that foundation, is for you to start laying that foundation of understanding to help you read the literature, to be able to start noticing what are those methods, what's the study design that was used, what were those methods that were used, for you to start assessing the degree to which those were appropriate methods. And so helping you read the literature and also helping you think a little bit differently as you think about your capstone. One of my goals for this course is to develop what I think of as research and statistics literacy. So as you listen to these short lectures, I would strongly urge you to jot down questions that you have and to post those questions on Raise Your Hand. The first concept is reliability. And here we're talking about reliability as it pertains to measures. Reliability as it pertains perhaps to the instruments that we're using to measure something. And reliability is quite simple. It's defined as consistency. If you are measuring someone's height 10 times in a row at the same time, you would expect all of those measures to be the same or almost exactly the same. And this would mean then that you have a consistent measure of height. The next concept is validity. Validity is a little more complex. But at its most basic level, validity refers to the truth of a conclusion that's based on study results. Another word we use is inference. Inference and conclusion mean about the same thing. So what are these inferences that we're deriving from the results of a study? So what is important about validity is that the validity of these conclusions are influenced by how we design the study. They're influenced by the methods that we use in that study and how carefully that study has been implemented. Reliability and validity are both important, but it's important to recognize that you can have a reliable measure that's not valid. So let's say we're measuring infants upon birth, and the scale that we're using is 5 ounces short. So every time an infant is measured, they're 5 ounces lighter than they really are. So we've got a consistent, maybe the scale consistently is 5 ounces short, but it's obviously then not giving us a valid measure. And so what this means is we must have reliable measures in order to support validity. We are going to talk about 4 main types of validity. Your Kim and Mallory textbook mentioned a couple of other more specific types of validity, but when we think about these main types of validity as first proposed in Shadish and Cook and then basically followed up by in Pollitt and Beck, these are the 4 main types. And we'll do them. The statistical conclusion validity will be covered in part 1, and the other 3 types will be covered in part 2. So we'll start with statistical conclusion validity. So let's just think about what that phrase means for a minute. So if you're doing a quantitative study, you collect data, and then you use different statistical methods to analyze that data. And so let's say you've analyzed your data, you get your results, and then you use those results to make conclusions or inferences. So are those conclusions valid? So one of the things that's important is having sufficient statistical power in order to support those conclusions. And now, what is statistical power? Well, Pollitt and Beck, who wrote a nursing research textbook, said that statistical power is this ability to detect a true relationship among variables. Let's say you're doing a study on the relationship of physical activity and type 2 diabetes. You want to know how those two variables are related. And you've done your study and you find a relationship. Did you have enough statistical power to say that this is a true relationship? The second bullet is how statistical power is defined by Shaders, Cook, and Campbell. And this is a classic book on study design to support validity. And it was quoted, this 1992 reference was quoted extensively in the Pollitt and Beck textbook. So I'm giving you both definitions here. So let's talk about these factors that can influence statistical power. I like to think of statistical power as this ability to detect a true signal from the background noise. And in research studies, that noise comes from error. And every research study has error in it. And there are these various sources of error. And so when we design a study, we want to design that study and conduct that study to maximize the signal and to decrease the noise. So we'll be talking about that more in this talk, and then throughout the semester we'll be continuing to talk about things that can decrease that noise. So some of the main factors. The first one is sample size. Imagine the amount of signal coming from a single voice versus 100 voices or 1,000 voices. So one way to increase power is by simply to increase your sample size. Another factor that influences that signal is how large of a signal is it? Do we have a large relationship between physical activity and type 2 diabetes, or do we have a small relationship? It's easier to detect a large relationship. Why? Because it's giving us a louder signal, a stronger signal, versus a small relationship is weaker. And sample size and relationship are, of course, related to each other. If we have a large signal, we don't need as many voices. We don't need as many participants to be able to detect that signal. On the other hand, if we have a very small relationship, we are going to need a larger sample size to be able to detect a true signal in the data. And one of the ways that we can get this larger relationship is by maximizing group differences. Let's say you're doing an intervention and you have a comparison group. You want that intervention to be a strong intervention that differs from that comparison group. So you have this, so you're generating results that are more likely to be different as a result of that intervention. You can think about, let's say you're doing an educational intervention and you've got patients who are getting these educational sessions and you have patients that don't. Well, you have to think about the patients who are in the comparison group. Could they be getting this information from other sources? Maybe they're looking online on their own and they're getting some of this intervention, but you're not measuring it because you're calling them a comparison group. So you have to think about how you design that intervention, how you implement that intervention, and the degree to which your comparison group is a true comparison group that's not getting the same things that your treatment group is getting, your intervention group is getting. So maximizing those differences will make it easier to detect that signal. Some other things to think about is when you implement that intervention, are you doing it the way you're supposed to? Is it being done consistently? Sometimes you might even have those educational sessions being given by different people. And so you can imagine there could be sources of noise or variability. We think of it as noise, and unmeasured variability is the same thing. So let's say two people are administering those education interventions somewhat differently. That could be a source of noise in your study. So all these come into play when we think about A, how we're designing our study, but also B, if you're doing an intervention study, how can you do it so that it's being done consistently and properly so that people are getting the same full dose? And in some cases, that's simply not possible. And the best thing then you can do is measure that variation in dose. Did the participants attend every one of those educational studies? Did they stay for the whole study or stay for the whole educational session? Or did some of them show up for only half the time and then they had to leave early because their babysitter had to go home? So these are all things that can be accounted for when a study is being designed that can increase that signal that they're getting from whatever we're looking at. Some other factors have to do with measuring. So let's say when we're measuring our outcomes, the results of that intervention, are we measuring the full range of what those outcomes can be? So let's say you have something that varies from 0 to 100, but your measures are only capturing part of that. They're capturing from 30 to 80. And that means you're missing those lower ranges of measures and you're missing the higher ranges. So you've got some noise, or you have some things that are not being measured as precisely as they can be. So that would decrease your power to detect that signal of how that intervention was affecting participants. We talked earlier about having these accurate and reliable measures. If they're not accurate and reliable, there's more noise. And the last point has to do for controlling for confounding variables, a concept that was covered in your readings and a concept that we'll talk about more in part 2 of this lecture.